Hello everyone, welcome to the video. Today we are going to discuss the very basics of recursion. If we understand the basics, we can apply these concepts to any problem that can be solved using recursion. So let's start, and if you are new to this channel, please don't forget to subscribe. Let's start. Let us say that we are given a problem P, any problem. For example's sake, we can consider that problem as factorial of a number. So what is given here is basically we are given an input as integer n and we have to return output as factorial of that number. Now how do we think about this problem in recursion manner? We need to ask ourselves this, that if somebody gives us the answer to just smaller problem, how and why we don't care. But if somebody just gives us that answer for smaller problem, can we use that answer to derive answer for our original problem? If we can, then this problem can be solved using recursion. And what does smaller problem mean here? Smaller problem would usually mean the smaller input. Let us apply this to our problem, factorial of a number. So what will be a problem that is just smaller than the problem which has input n? It will be factorial n minus 1. Now let us say somebody gives us this value. How do they calculate it? We don't care. But if somebody gives us this value, can we use this value to calculate the value of factorial n? Yes, we can, because factorial of n is nothing but n into factorial of n minus 1. So if somebody gives me this, I will multiply that by n to get my answer for factorial n. Now this is called recursive relation. So what is recursive relation? Recursive relation is relation between answer for our just smaller problem like factorial n minus 1 and answer for our original problem like factorial n. So whenever we will be solving any question that involves recursion, we will have to derive something called as recursive relation. Once we derive that, writing algorithm is very simple. So if we try to write the algorithm for our factorial method, it will be very simple. We will have a method that takes an argument as integer n and it will return n into factorial n minus 1. Here basically we are calling the same method again but with a different input and precisely a smaller input. This is the characteristic function of recursion. In recursion, we call the same method again and again. The method calls itself again and again. But is this algorithm complete? Will this work? No. Why? Because this will go into infinite loop. We are calling the same method in its body. So it will keep on calling itself again and again and it will go into infinite loop. So how do we stop that? That is where the term base condition or terminating condition of recursion comes in. The base condition or terminating condition is reached when the input is smallest. And in this factorial function, what will be the smallest input? The smallest input will be when n reaches 0. And we know that 0 factorial is equal to 1. So we add this base condition that if n's value is 0, then return 1. Now this method will not run infinitely. There is a terminating condition for this recursion and therefore this is complete. There is also a big disadvantage of using recursion. It is that it consumes a lot of memory. Why? Because in general, any method call occupies some space in the memory. So here factorial n occupies some space in memory. Then the next call factorial n minus 1 occupies some space in memory and so on. Now this is not done till factorial n minus 1 is resolved and so on till we reach the base condition. So the deeper the recursion is, more is the number of method calls and more is the space occupied on memory. To summarize, if we have to think for any problem using recursion, we should ask ourselves, if somebody can give us answer to the smaller problem, can we use that answer to derive answer for our original problem? Smaller problem would often correspond to smaller inputs. So we should be able to derive a recursive relation. Recursive relation will be the relation between answer of our just smaller problem to answer of our original problem. Then once we have derived the recursive relation, the only thing left will be to find out what will be the base or terminating condition. And we will find that often at the smallest possible input. One thing to keep in mind while using recursion is that recursive method calls take up space in memory that can be expensive. This is it for this video. In the next few videos in this playlist, we will use recursion to solve some of our problems. Did this video help you in understanding recursion a bit better? Please let us know in the comments. Also, please don't forget to like the video and subscribe to the channel. We will meet again in the next video with some other problem. Thanks for watching.